This video focuses on distance time graphs, and in particular I'll be going over how to interpret a distance time graph and how to interpret a distance time graph in which the speed is varying. This is what a simple distance time graph looks like. Sometimes you'll get them called dt graphs, but that just means distance, time. On the y-axis you have distance, and on the x-axis you have time. This diagonal straight line represents a constant speed. A line curving upwards like this shows an acceleration. A line curving to a plateau like this shows a deceleration. And finally, a flat line on a distance time graph shows an object that's stationary. Now, the reason we can say that each of these curves, these flat lines and whatnot, are an acceleration, deceleration, whatever, is because the gradient of the line is equal to speed. You can see that because the gradient would be change in y over change in x, so the distance over the time, and we know that speed is equal to distance over time. You also need to understand that the steeper the line is, the quicker the object is moving, and conversely, the shallower, the flatter the line is, the slower the object is moving. Here, the dashed pink line represents a steep gradient, which means the object is moving faster. The green shallow line means the object is moving slower because it's got a lower gradient. You can see that with the pink line, as you move along the time axis, the distance increases a lot quicker than as you move along the time axis for the green line. That means you're covering more distance in a shorter amount of time. In other words, you're moving a lot faster. It's good and all knowing how to interpret these simple distance time graphs, but what happens when we have something like this? In everyday life, we aren't just moving at the same speed. We stop, we slow down, we speed up. This is what all of that looks like on a distance time graph. For the first 20 or so seconds on this graph, the object is moving at a constant speed. We know that because the line is a diagonal straight line. How would we figure out the speed? As I said earlier, the speed on a distance time graph is equal to the gradient of the line, so we just find out the gradient of this line. As it's right at the origin, it's quite easy to figure out the gradient. The change in y and the change in x can be calculated by just picking a point on the line. So let's say at the time 30 seconds, and reading that across, we find out that it corresponds to 15 meters. So in 30 seconds, the object has covered a distance of 15 meters. That tells us its speed is 0.5 meters per second, and its gradient is also 0.5 meters per second. But what if I wanted to find out the speed of the object at around 120 seconds? That part curves upwards, telling us that the object accelerates. But how do we get the gradient of a curve? To do that, we first need to draw a tangent, so a line that just touches the curve, and calculate the gradient of that line. So I've got my tangent here. I'm going to draw a triangle to help me calculate the gradient, and reading the values across for the y-axis first, we can see that it goes from 10 meters all the way to 30 meters, so that's a change of 20 meters, and on the x-axis it goes from around 75 seconds to 160 seconds, which is a change of 85 seconds. From this, we get a gradient of 20 over 85, and that's equal to 0.235. Which rounds down to 0.24 to two significant figures. And that's our speed. So the speed is 0.24 meters per second. That was a brief overview of distance time graphs. In the next video, I'll also go over velocity time graphs. But I'll end this video here with this one tip. When you're asked to describe a distance time graph, in words that is, include points such as the average speed, so take the overall distance and divide it by the overall time to get the average speed. Where the object is stationary, so where there is a flat line, and areas where the object is accelerating or decelerating, so areas that are curved.